Welcome to this explainer from Discovery Room, where curiosity comes alive. Today, we're diving into the ultimate cosmic crime scene to explore one of Earth's greatest mysteries. For over 160 million years, dinosaurs ruled the Earth. Then, almost overnight, they vanished. What happened? Just picture it. A thriving world 66 million years ago. Giant reptiles absolutely dominating the land, the sea, and the sky. And then, poof, an entire global ecosystem is just completely wiped away. So how do we even begin to solve a 66 million-year-old cold case? Let's get right into it. Section 1. Finding the smoking gun. So, all around the world, buried deep down in the rock layers, there sits this incredibly thin, dark line of clay. We call it the KPG boundary. And it's absolutely fascinating because below this line, dinosaur fossils are everywhere. But above it, nothing. Zilch. In 1980, a father and son team, Luis and Walter Alvarez, were actually studying this exact clay boundary in Italy, and they discovered it was packed with unusually high levels of iridium. Now, iridium is a metal that's incredibly rare on Earth's crust, but, and here's the kicker, it is highly common in carbonaceous asteroids. Well, this wild discovery led to what we now call the Alvarez hypothesis. They boldly proposed that the mass extinction of the dinosaurs, and actually about 75% of all species on Earth at the time, was caused by a massive asteroid impact. Now, this was a huge, groundbreaking idea. It sent scientists on this frantic global hunt to find a crater big enough to match the theory. And eventually, they found it, buried deep in the Yucatan Peninsula in Mexico, the massive Chicxulub crater. Section 2. Ground Zero, the impact. To really grasp the sheer, terrifying scale of what hit us, let's look at a quick comparison. The Chicxulub asteroid was estimated to be somewhere between 10 and 15 kilometers wide. If you took that space rock and rested it at sea level, it would literally tower over Mount Everest. Just imagine that for a second. A mountain larger than Everest, falling from the sky at a blistering 20 kilometers per second. When it slammed into the shallow sea of the Yucatan, the collision released energy equivalent to 100 million megatons of TNT. To put that completely mind-boggling number into perspective, that is over 1 billion times greater than the energy of the atomic bombs dropped on Hiroshima and Nagasaki. 1 billion. The immediate aftermath was just incomprehensibly violent. The strike instantly punched a massive hole, a cavity 30 kilometers deep, right into the Earth's crust. It shocked and melted basement granite from deep within the Earth, launching vaporized rock, molten material, and sediment tens of kilometers high into the upper atmosphere. The timeline of destruction here is just incredibly rapid. We're talking an escalation from localized devastation to a full-blown global catastrophe in basically no time. Within seconds, that 30-kilometer deep crater is formed. Within minutes, the burning hot ejecta falling back to Earth creates an intense thermal pulse. It's kind of like the whole planet being shoved into an oven set on broil, which quickly ignites widespread wildfires. Within hours, the displaced ocean water creates mega tsunamis. And over the following years, a devastating, suffocating impact winter sets in. The sheer force of the impact triggered colossal seismic activity across the ancient oceans. We're talking earthquakes estimated at up to a magnitude 11.5. And it spawned mega tsunamis over 100 meters tall. These monstrous waves violently surged across the globe, basically scouring the seafloors clean and completely devastating coastal environments thousands and thousands of kilometers away. Section 3. The impact winter. Now, the asteroid happened to hit literally the absolute worst possible place it could have, a shallow seabed made of gypsum, which is incredibly rich in sulfur. The impact vaporized hundreds of billions of tons of this sulfur, along with rock and soot from all those global wildfires, and injected it straight into the stratosphere. This dispersed a massive, thick aerosol cloud that quite literally enshrouded the entire planet. Talk about catastrophically terrible look. And so, a physical impact rapidly turned into a global biological nightmare. First, all that dust and those sulfates blocked the sun, plunging the planet into darkness for maybe up to a decade. With no sunlight, global temperatures absolutely plummeted, and photosynthesis completely ground to a halt. When the plants and the marine phytoplankton died off, the entire food chain just collapsed worldwide. The large herbivores starved, and, well, soon after, the carnivores followed. Section 4. The Survivors. Amidst this frozen, dark world, survival really came down to a stark set of ecological filters. The doomed were the large animals with specialized diets, the ones heavily reliant on vast amounts of live plants or fresh prey, like the mighty T-Rex or Triceratops. They simply couldn't find enough calories to keep going. But the survivors? They were these small, scrappy generalists, the burrowers and scavengers that could make a meal out of dead organic matter. I'm talking about our early mammalian ancestors, crocodilians, and small, feathered avian dinosaurs. The oceans, unfortunately, suffered a terribly similar fate. Those vaporized sulfates up in the atmosphere caused highly corrosive sulfuric and carbonic acid rain to pour down, which rapidly altered the water's chemistry. This severe ocean acidification dissolved the shells of vital marine plankton. It basically wiped out the very foundation of the ocean food web, ultimately dooming the giant marine reptiles that once ruled the seas. Section 5. The Dinosaurs Among Us. Now, while this was an absolute apocalypse for so many, this mass extinction event emptied out countless ecological niches. It completely reset the board. The humble survivors suddenly had a wide-open world to conquer. And this led to a phenomenal period of adaptive radiation in the Cenozoic era. Those small, surviving mammals diversified incredibly fast into the myriad forms we know today: horses, whales, bats, and eventually us primates. And those surviving feathered avian dinosaurs, they radiated into the astonishing diversity of all modern bird species we see across the globe today. Which brings us to our final thought for this explainer. The dinosaurs disappeared, but their story didn't end. In a way, they're still with us today, in the birds flying above our heads. It really leaves you wondering, doesn't it? If that asteroid had struck the Earth just a few minutes earlier or later, missing that shallow, sulfur-rich sea, would humans even be here today to ask the question? Thank you for joining me, and I'll catch you next time.